I remember when I was a kid, I used to see math problems that looked kind of like this. I guess this is a fairly famous one where the goal is to assign digits to each of the letters so that the addition worked out correctly. I was never very interested in these. I'm still not very interested in these. What I want to share with you right now is a phenomenon, and the explanation for the phenomenon gets into some of the same issues, perhaps, that are included in solving a little puzzle like this. What I'm going to do might start out looking a little familiar, but there's a little strange turn at the end, and I'd like for you to hang in there for the strange turn. Okay, so you might know what to expect for the decimal if I asked for what's 648 divided by 999. If you've worked with repeating decimals before, you may already know what to expect that to be, but I want you to bear with me. I'm actually going to do the long division. Okay, let's see. I think I can fit 6 of those in there. And I get a remainder of 486. I'll bring down another 0. I think I can get 4 of those in there. Get 864. Bring down another 0. I'll fit 8 of them in there. Subtract, and I get 648. And now, as you may know, I'm back to where I started. The remainder at this point is 648, and I'm dividing 999 into 648. So I expect this now to continue ad infinitum. Okay, so that's the part you may be familiar with. I want to show you something else. Look at the, and you may have already noticed this while I'm talking here. Look at the, I started out with 648, and the next remainder I got was 486, and then the next remainder I got was 864. 648 became 486, which became 864, and then I went back to 648. Okay. That's a kind of a peculiar pattern, isn't it? You see the digits rotating there. Let me show you another one to maybe clarify what's going on. This one I won't make you sit through my long division. I divided 9,999 into 3,508. And look at the pattern that appears in the remainders as I move through there. It went 3508 to 5083 to 835 to 8350. So I hope you're seeing the rotating digits, which is sort of a little structure in there that I didn't know until I bumped into this. Okay, so I suggest that you try one of these for yourself. Divide, start with the proper fraction where the denominator is 9 or 99 or 999 or 9,999, etc. And perform the divisions carefully and look the division carefully and look at your sequence of remainders and see if you see such a rotating pattern. Of course, the question here, the question of the day is, can you find an explanation for this? I like this puzzle because it is kind of like the Sin More Money puzzle, except that it's the Sin More Money puzzle looked so entirely man-made, so artificial and man-made, and this is actually like a structure, something going on inside of division. It's there whether or not human beings are here. I think this thing is going on. Okay, so and I just greatly prefer math problems that make me feel like I'm learning things about the universe. Okay, so that's that, but I did want to show you one more thing. This is kind of a interesting one. You may be wondering, what is it about 9 or 99 or 999 that makes this stuff work. And you may have wondered that about in the past, what it is about 9 or 99 or 999 in various situations. I'd like to do another one. I'd like to do 24 over 37. Yeah, so my next problem is going to be 24 divided by 37. So I'm going to divide 37 into 24. I've already done this. And look at what I get there. The remainders this time are 24 and then 18 and then 32. There may be something going on with those numbers, but it's certainly not a rotating pattern like we had. It looks like dividing by 99 is just special. But then notice that this turned out to be the same repeating decimal we had before. And so 24 over 37 must be the same thing as the fraction we had before, 648 over 999. It is, in fact, because you can factor 648 over 999 as 24 times 27 over 37 times 27. Okay, but look at what happens with these the remainder pattern. If you multiply each of those by 27, you get 648, 486, and 864. The same remainders we got just a minute ago. Here was that just a minute ago. Okay. So one last little bit about this. What this means is, when you're doing a mundane standard division like 48 over 123, that is fairly randomly chosen, 48 over 123, when you do the division, you'll get a sequence of remainders, and they won't look like much at all. They look about as random as you're going to get. Okay. But, so what you have to do then, there's a secret number in this problem, in any division problem. Think about, for 48 over 123, could I write this as something over 90? Could I write this as something over 999, or now 9,999, or 99,999? And the answer is yes. I can write it as 39,024, which you may have known from the quotient up there, over 99,994. And all you have to do is multiply top and bottom, as the kids say, by 813 to get 39024 over 99,999. Okay, so 813 is kind of the hidden number in this problem, because now if I take these numbers and multiply by 813, well, I know here I'm going to get 39024. So this pattern that looked like it had no particular meaning of remainders in here, if you figure out the number for this denominator that gets it to a sequence of 9s as a number, well, then that number, when multiplied by the remainders, produces something that says these numbers are very far from being random. You get 90243, 2439, 24390, and 43902. The same rotating pattern. So the numbers that looked like they were nothing and for most of my life meant nothing to me, would have meant nothing to me, now I know there's some greater meaning. They actually belong, when multiplied by the correct number, to come from a number that has this cycling pattern, this rotating pattern. Okay, I just thought that was kind of fun as a little mind blower at the end. But the real question here is, why do you get that division by 9 or 99 or 999 rotates the digits the way it does? Okay, I'll leave you with that problem. Thanks.